Hello students, myself Dr. Amritpal Singh, and I welcome you again on this online learning platform. So, just write your name in the comment box so that I can know how many people they are present. So, in the first 5 minutes, we will mark your attendance. So, in this lecture, we will talk about some structure about the nucleus in detail, and then we will discuss how the nuclear forces so they comes in line, and before these nuclear forces, what are the theories which worked behind? We will discuss the Thomson plum pudding model, then we will discuss the Rutherford alpha scattering experiment, and after that Rutherford proposed the proton-electron theory, and then we will discuss the limitations of this proton-electron theory, and after that we will discuss proton and neutron theory, and in that we will discuss why electron they cannot exist within the nucleus, and how the existence of neutrino particles they come into line. So, starting our lecture, so first of all, in the year 1897, Sir J.J. Thomson he proposed a hypothesis. So, what he said that the atoms they are considered as a sphere of positive charged particle in which electrons they are embedded in between. So you can see that so the proposed the structure something like a watermelon model, and what he said that the atom which is spherical in shape, and the positive and negative charged particles they are exist all across the atom, and they are randomly distributed, something like you can see that the red pulp of this watermelon, he has said that this is the positive charged, while the electrons, the seeds of this watermelon, so they are something like present in the atom. And he also gave the name to this as the resin bun model, and it is something like a chocolate cake having some choco chips present in between. But so what basically he said that the radius of atom it was estimated to be of the order of 10 is to power minus 10 meter. So I will write here. So he proposed the radius that is approximately of the order of 10 is to power minus 10 meter, and the emission of electron by atom and the independent existence of electron was convincing, and it shows that the electron there also exist within the atom structure. But this model so it has some failure. So the next model which has been proposed, that is by the Rutherford alpha scattering experiment. And what Rutherford said that he was bombarding some alpha particle from all across different nuclei, and you can clearly see. So according to Thomson, so if there are protons and electrons, they are randomly distributed, then the majority of the alpha particles they ray should be undeviated. But what Rutherford observed that so they rays which are falling far away from the center of the atoms, so they are undeviated. while the rays alpha particles which are passing from the center of the atoms, so they are getting scattered at different angles. So you can see also from this figure, so this alpha particle, it has been scattered at this angle, this has been scattered at this angles. So what he was doing is he was bombarding the alpha particle to a gold foil. So this is the experimental structure of the alpha scattering experiments. So this is the beam of alpha particle, and which is being shoot out at a gold foil, and the thickness of this gold foil, that is of the order of 4 into 10 is to power minus 6 meter, or you can say that is of the order of 4 micron. And as we all know that the size of the atom, that is of the order of 10 is to power minus 10 meter, and which is very less as compared to the size of this gold foil. So he observed that some alpha particles, so they are deflected at some acute angles, some are getting reflected at a large scattering angle, so and so. So he proposed with some conclusions, and what Rutherford comes to the conclusions that the atoms has a large empty space, and most of the alpha particles pass through, and most of the alpha particles, they pass undeflected, because he discovered or observed the deflection mostly at the center of atom. So again, this is against the Thomson J.J. Plum Mooding model, because what Thomson said that all the atom, it is occupied with positive and negative charged particles, and they are randomly distributed. While Rutherford observed that most of the atom, it is having a large empty space, and because there is no deflection he has observed apart from the center of the atom. So second point, he concluded that a lump of mass at the center of atom is present, and he gave the term nucleus. He called this as the nucleus of the atom. And then he said that, so this lump of mass, it is mostly a positive charge, because alpha particle which is having also a positive charge, and these positive charges, they are being deflected, or they are being repelled by these positive charged particles which are present in the center of the atom, because positive and positive, they repel each other. So this is our alpha particle, this is the positive charge which is present in the nucleus, and due to the large angle of scattering of this alpha particle, he observed that, so the lump of mass which is present in the center of atom, it is a of positive charge. So next he said that there are just enough electrons outside the positive charge nuclei to provide a balance of positive and negative charges. So Rutherford done some calculations, and he calculated that the diameter of the nucleus of the atom, which is found to be of the order of 10 to the power minus 15. So from the experimental results, so he done some calculations, and he said that the diameter of nucleus, that is of the order of 10 to the power minus 15, while the diameter of the atom, it is of the order of 10 to the power minus 10 meter. And from that, so in order to simplify the relation between the atom and the nucleus, he derived a new term that is known as the 1 angstrom, so which is of the order of 10 to the power minus 10 meter, or you can say that is 10 to the power minus 8 centimeter. Now he gave one term that is known as the distance of nearest approach. So what he said that suppose this is our nucleus, so this is our atom, and the alpha particles which are being striking, and they get scattered back, and the distance, this distance, that is actually these alpha particles, they are not directly interacting with these positive charged particle, and the distance at a distance, so from that distance these particles, they are getting scattered, and this distance is known as the distance of nearest approach. And what he said, basically how he calculated the value of this distance of nearest approach, and in some books it is being derived with the term b. And what he said that let the alpha particle is having a energy that is of the order of E, and the mass of this alpha particle, it is m, and he said that the kinetic energy of these alpha particle, so which are being striking to this atomic structure, and that is of the order of mu square. So where u will be the velocity with which these alpha particles they are moving. Now what he said that as these alpha particles they approaches the nucleus, ਹੁਣ obvious ਹੈਗਾ ਹੈ ਕਿ ਜਦੋਂ ਵੀ ਕੋਈ ਜਿਹੜਾ particle ਹੈ, it will trying to interact with some other particle, it will lose some of its energy and transfer that energy to the another particle. So ਉਸ ਕੇਸ ਦੇ ਵਿੱਚ ਕੀ ਕਿਹਾ ਉਹਨਾਂ ਨੇ कि the kinetic energy of this alpha particle, it is gradually being converted to electrostatic potential energy, because there are some sort of electrostatic Coulomb interactions which are present on these positive charged particles. So ਜਿਹੜੀ kinetic energy it is being converted to potential energy, and at a point that is known as this distance of nearest approach, so the fully kinetic energy is being converted to totally to potential energy. So ਉਸ point ਦੇ ਉੱਤੇ ਉਹਨਾਂ ਨੇ ਕੀ ਕਿਹਾ कि kinetic energy ਜਿਹੜੀ ਆ it is being converted into potential energy due to these Coulomb's forces of repulsion. So when we equate this kinetic energy that is of the order of potential energy, so ਇਸ point ਦੇ ਉੱਤੇ ਕੀ ਆ ਕਿ ਜਦੋਂ ਜਿਹੜੀ ਸਾਰੀ ਦੀ ਸਾਰੀ kinetic energy ਜਿਹੜੀ potential energy ਦੇ ਵਿੱਚ convert ਹੋ ਚੁੱਕੀ ਆ, and so ਉਸ potential energy ਦੀ ਜਿਹੜੀ value ਆ, so that we can calculate, that is of the order of 1 over 4 pi epsilon naught charge on alpha particle, that is Zt, and charge on this nucleus, that is 2 times Z over R naught. So let us say this is our equation number 1, this is equation number 2, and when we equate these two equations, so half mv square mu square, that is of the order of Zd into 2e over 4 pi epsilon naught into R naught, and from that we can calculate the value of this R naught, 2z e square over e, and when you put these values, so it is of the order of z e square over pi epsilon naught mu square. So this relation gives us the idea कि किस distance तो जड़ा alpha particle आ वो travel जड़ा है वो back कर रहा है, and what is the minimum distance which exists between the alpha particle and the nucleus, and if we know the mass of this alpha particle u, if we know the velocity of this alpha particle, so जिन्नी ज़्यादा जड़ी ओदी velocity ज़्यादा होएगी अल्फा पार्टिकल दी, सो हायर द एनर्जी ऑफ दोज अल्फा पार्टिकल, सो उन्ना जिहड़ा डिस्टेंस आ आर नॉट दा घट होएगा. सो व्हाट डज इट मीन्स, सो मोर क्लोजली इट कैन अप्रोच द न्यूक्लियस. So this relation is quite useful when we calculate numericals related to the alpha particle interaction with the nuclei. And we will also do one numerical related to this. ਹੁਣ ਇਸ ਕੇਸ ਦੇ ਵਿੱਚ ਕੀ ਹੈ ਕਿ ਜਦੋਂ ਜਿਹੜੀ ਇਹ ਡਿਸਕਵਰੀ ਹੋਈ ਰਦਰਫੋਰਡ ਦੀ, ਉਹਨੇ ਜਿਹੜੀ ਡਿਸਕਵਰੀ ਆ ਦੈਟ ਇਜ਼ 1913 ਦੇ ਵਿੱਚ ਦਿੱਤੀ. ਸੋ ਉਹਦੇ ਤੋਂ ਬਾਅਦ ਜਿਹੜਾ ਰਦਰਫੋਰਡ ਆ ਉਹਨੇ ਇੱਕ ਮਾਡਲ ਪ੍ਰਪੋਜ਼ ਕੀਤਾ, ਸੋ ਦੈਟ ਇਜ਼ ਨੋਨ ਐਜ਼ ਦੀ ਪ੍ਰੋਟੋਨ-ਇਲੈਕਟ੍ਰੋਨ ਹਾਈਪੋਥੇਸਿਸ. ਸੋ बिकॉज उस टाइम के उत्ते जी न्यूट्रॉन की जी डिस्कवरी नहीं हुई सी, बिकॉज वी आल नो दैट दी डिस्कवरी ऑफ न्यूट्रॉन. सो उस टाइम के उत्ते साडे कोल जिहड़ी आ सानू ये नहीं पता सी कि इदां दा कोई पार्टिकल एग्जिस्ट करता है जिहड़ा न्यूट्रॉन आ, जिहदा नाम चैडविक ने जिहड़ी ये डिस्कवरी दित्ती सी. सो इन 1932 ਦੇ ਵਿੱਚ ਜਿਹੜੀ ਹੈ ਡਿਸਕਵਰੀ ਹੋਈ ਹੈ. ਸੋ ਤੋਂ ਪਹਿਲੇ ਜਿਹੜੀਆਂ देयर आर ਨੰਬਰ ਆਫ ਹਾਈਪੋਥੇਸਿਸ ਵਿਚ ਕਮਸ ਇਨਟੂ ਲਾਈਨ ਕਿ ਨਿਊਕਲੀਅਸ ਦੀ ਸ਼ੇਪ ਕਿੱਦਾਂ ਦੀ ਹੋ ਸਕਦੀ ਆ, ਉਹਦੇ ਵਿੱਚ ਕਿਹੜੇ ਕਿਹੜੇ ਪਾਰਟੀਕਲਸ ਐਗਜ਼ਿਸਟ ਕਰ ਸਕਦੇ ਆ. So the work of Rutherford and others established that the size of nucleus, so that is very small as compared to size of the atom, and its density that is very large in magnitude. And at that time the natural discovery radioactivity ਦੀ ਜਿਹੜਾ discovery ਆ ਉਸ ਟਾਈਮ ਦੇ ਉੱਤੇ ਹੋ ਚੁੱਕੀ ਸੀ. ਹੈਨਰੀ ਬੈਕਵਰਲ ਨੇ ਜਿਹੜੀ ਆ ਉਹ 1901 ਦੇ ਵਿੱਚ ਲਗਭਗ ਜਿਹੜੀ ਆ radioactivity ਦੀ discovery ਹੋ ਚੁੱਕੀ ਸੀ. And that natural radioactivity suggests that through the nucleus, so there is some sort of particles which are coming out like alpha particle, emission of beta particle and gamma radiations. So these study of radioactivity, it reveal that there is some sort of discrete energy levels which are present in the nucleus, and from the spectrum of beta particle it is suggested that there is some sort of another particle which also present in the nucleus, and they gave the name it as a neutrino. And further neutrino hypothesis ने जड़ा है ये मॉडल दिता सी, ਉਹਦੇ ਬਾਰੇ ਵੀ ਆਪਾਂ ਜਿਹੜੀ ਆ डिटेल ਦੇ ਵਿੱਚ ਗੱਲ ਕਰਾਂਗੇ. ਹੁਣ ਜਿਹੜਾ ਇਹ प्रोटॉन इलेक्ट्रॉन थ्योरी आ, सो ਇਹ ਕੀ ਸੁਜੈਸਟ ਕਰਦੀ ਆ, सो प्रोटॉन इलेक्ट्रॉन थ्योरी जिहड़ी रदरफोर्ड ने दित्ती सी, so what it suggests that electrons are emitted, so proton and electron theory suggests that the proton and electron which are present within the nucleus and within the atomic structure, and so these electrons, so which are emitted by radioactive nuclei in beta decay process. Second, the mass spectrum data. From the mass spectrum data, it has been found that masses of different nuclei are whole numbers, because उस time ਦੇ ਉੱਤੇ ਜਿਹੜੇ ਜਿੰਨੇ ਵੀ ਐਟਮਸ ਜਾਂ ਅਟੋਮਿਕ ਨੰਬਰ ਸਾਡੇ ਕੋਲ ਸੀ, ਸੋ ਉਹਨਾਂ ਦੇ ਜਿਹੜੇ ਮਾਸ ਨੰਬਰ ਆ, ਸੋ ਦੇ ਆਰ whole number multiples of ਹਾਈਡਰੋਜਨ। ਹੁਣ ਕਿਸੇ ਵੀ ਜਿਹੜਾ ਐਟਮ ਆ ਜਾਂ ਕਿਸੇ ਵੀ ਐਲੀਮੈਂਟ ਦਾ ਜਿਹੜਾ ਮਾਸ ਨੰਬਰ ਆ, ਆਪਾਂ ਇਹ ਰਿਪਰੈਜ਼ੈਂਟ ਕਰਕੇ ਦੱਸ ਸਕਦੇ ਸੀ ਕਿ ਕਿੰਨੇ ਨੰਬਰ ਆਫ ਜਿਹੜੇ ਪ੍ਰੋਟੋਨ ਆ ਉਹਦੇ ਵਿੱਚ ਪ੍ਰੈਜ਼ੈਂਟ ਹੈਗੇ ਆ, ਬਿਕੋਜ਼ that time proton ਜਿਹੜਾ ਆ, so one hydrogen atom it is represented as one proton. So the hydrogen nucleus was given the name proton. So hydrogen nucleus ਨੂੰ ਉਸ ਟਾਈਮ ਦੇ ਉੱਤੇ ਪ੍ਰੋਟੋਨ ਦਾ ਨਾਮ ਦੇ ਦਿੱਤਾ ਗਿਆ in order to explain the structure of other atoms. While a slight change in the atomic masses from the whole number, it has been explained that the presence of isotopes, ਕਿ ਜੇ ਕਿਸੇ ਐਟਮ ਦੇ ਵਿੱਚ ਜ਼ਿਆਦਾ ਆਈਸੋਟੋਪਸ ਹੈਗੇ ਆ, ਸੋ ਉਹਨਾਂ ਦਾ ਜਿਹੜਾ ਮਾਸ ਨੰਬਰ ਆ, ਸੋ that is slightly different. So atom as a whole that is considered as neutral, ਕਿ ਇੱਕ ਐਟਮ ਦੇ ਵਿੱਚ ਜਿੰਨੇ ਨੰਬਰ ਆਫ ਪ੍ਰੋਟੋਨਸ ਹੈਗੇ ਆ, ਉਨੇ ਨੰਬਰ ਆਫ ਜਿਹੜੇ ਆ ਉਹ ਨਿਊਟਰੋਨਸ ਜਿਹੜੇ ਆ ਉਹ ਪ੍ਰੈਜ਼ੈਂਟ ਹੈਗੇ ਆ। ਸੋ ਐਟਮ ਇਜ਼ ਕੰਸਿਡਰਡ ਐਜ਼ ਨਿਊਟਰਲ। Because the number of protons is equal to number of electrons in the atom. So let us take one example. So ਉਹਦੇ ਵਿੱਚ ਉਹਨਾਂ ਨੇ ਕੀ ਕਿਹਾ ਕਿ ਕੁਝ ਜਿਹੜੇ ਇਲੈਕਟ੍ਰੋਨਸ ਆ, so they are present within this nucleus, while some electrons, so they exist outside this nucleus. So this is the hypothesis of proton-electron theory. But the total number of protons and electrons that is equal in a particular atom. So for a nitrogen gas structure, so what they said that it has 14 protons and 14 electrons. So ਉਸ ਕੇਸ ਦੇ ਵਿੱਚ ਉਹਨਾਂ ਨੇ ਕੀ ਕਿਹਾ ਕਿ ਕਿਉਂਕਿ ਦੋ ਨਾਈਟ੍ਰੋਜਨ ਦੇ ਐਟਮ ਹੈਗੇ ਆ, so 7 atomic number ਇੱਕ ਦਾ, 7 ਇੱਕ ਦਾ, so total 14 protons they are present, and this structure is something like this. So this is our nucleus. So 14 proton which are present in the nucleus, 7 electron they are present within the inside of nucleus, while 7 electrons they are present outside the nucleus in order to keep this number same. So 14 proton is equal to 14 electron, and the atom is considered as overall neutral atom. So these are some of the points which proton and electron theory proposed. However, this theory get failed. So what are the failures of this theory? So failure of proton-electron hypothesis. So first point they failed to explain is that is the wave mechanical consideration. ਹੁਣ ਉਸ ਕੇਸ ਦੇ ਵਿੱਚ ਕੀ ਸੀ ਕਿ if the electron it is present inside the nucleus, then it should follow the Heisenberg uncertainty principle. So if we suppose that the radius of the nucleus that is of the order of 10 to the power minus 14 meter, and the uncertainty in the position of the electron is equal to the diameter of the nucleus. And suppose this is our nucleus and it is having a diameter that is of the order of 10 to the power minus 14 meter, two times, because radius is 10 to the power minus 14 and diameter is 2 into 10 to the power minus 14 meter, and the existence of electron, it should lie within this nucleus, and how much distance, that is of the order of 2 into 10 to the power minus 14 meters. So the existence of the uncertainty in the position of the electron, that is of the order of delta x, it should be equal to the diameter of the nucleus, and from the Heisenberg uncertainty principle, which we know that the change in position into change in momentum, that should be of the order of Planck's constant. And once we know the uncertainty in the position of the electron, from that we can calculate the uncertainty in the momentum of that electron, and putting these values, so h bar here, that is of the order of h over 2 pi divided by delta x, and from that you can calculate it is of the order of and it comes out to be 0.527 into 10 to the power minus 20 joule second meter inverse. And once we calculate the change in momentum of electron, from that we can calculate the energy of electron which are being emitted from the nucleus, and this is the total energy, which is p square c square. So this momentum, that is of the order of p, and m naught c square, that is the rest mass energy of electron. So this is rest mass energy of electron, and that you have calculated the value of this m naught c square, that is of the order of 0.511 mega electron volt, and this we have derived in our previous lecture. So putting all these values, the value of p we know, c is the speed of light with which these electrons, so they are coming out of the nucleus, and the value of this energy, that is coming of the order of 200 mega electron volt. So what does it means? So it means that if electron exists inside the nucleus, their energy must be of the order of 200 mega electron volt. However, we all know that the electron emitted by a radioactive nuclei during beta decay, that is having a energy of the order of 3 to 4 MeV. So ਉਹਦੇ ਤੋਂ ਪਹਿਲੇ ਜਿਹੜੀ ਆ ਦੀ ਰੇਡੀਓਐਕਟਿਵ emission of beta decay ਨੇ ਜਿਹੜੀ એનર્ਜੀ ਕੈਲਕੂਲੇਟ ਕੀਤੀ ਸੀ, that is of the order of 3 to 4 mega electron volt, and there is a huge difference. You can see that, so one point it is saying that the electron which are present within the nucleus, so they are having 200 mega electron volt energy, while the radioactivity theory, they says that the beta particles which are coming from the nuclei, they are having so 3 to 4 MeV of energy. So that's why this theory, that is the proton-electron theory, it get failed, and from that we can say that the electron do not exist in a nucleus. And the second point, so where this get failed, so that is due to the nuclear spin. Now there are difficulties to explain the nuclear spin through this proton-electron theory. Now if we take the case of nitrogen, and so that is having 4 proton and 7 electron which are bound within the nucleus, and that is total 21 particles which are present within the nucleus, and when we calculate this 21 particle, so this is last particle that is having half integral spin. While on the basis of experimental data suggest that N2 has integral spin. So here again the proton-electron theory, it get failed because it did not explain the nuclear spin of each particle correctly. So third point, that is, it did not explain the nuclear magnetic moment as well, because the magnetic moment of electron, that is almost 8136 times greater than the magnetic moment of proton. So this we have calculated. So the Bohr magnetron, that is almost 1836 times greater than the nuclear magnetron. And if electron exists within the nucleus, according to this proton-electron theory, the magnetic moment of electron will dominate. But it has been found experimentally that the magnetic moment of nucleus is much smaller than the magnetic moment of this electron. Experimentally, it has been found that the nucleus magnetic moment, that is very small as compared to electron magnetic moment. So again here proton-electron theory, it get failed. So another point is, it did not explain the Compton wavelength, that is the wavelength of the electron which are coming out of the nucleus, so that did not match the value of the experimental data. So this you can also calculate. Now the value of this Compton wavelength, that is of the order of h over MEC, and when you calculate this, so where 6.63 into 10 is to power minus 34 joule second over mass of electron 9 into 10 is to power minus 31 into 3 into 10 is to power 8, and the value of this wavelength, that is of the order of 245 times the nuclear diameter. So thus the Compton wavelength of electrons comes out to be 242 times 10 is to power minus 14 meter, and which is 100 times greater than the nuclear radius. ਹੁਣ ਜਿਹੜਾ ਨਿਊਕਲੀਅਸ ਦਾ ਰੇਡੀਅਸ ਆ ਉਹ ਆਪਾਂ ਕੰਸੀਡਰ ਕਰਦੇ ਆ, that is of the order of 0.12 into 10 is to power minus 14 meter, but the wavelength of the emitted electron, it is coming out to be 242 into 10 is to power minus 14 meter, and ਕੋਈ ਪਾਰਟੀਕਲ ਜਿਹੜਾ ਨਿਊਕਲੀਅਸ ਦੇ ਵਿੱਚ ਐਗਜ਼ਿਸਟ ਕਰ ਰਿਹਾ ਆ ਔਰ ਉਹਦੀ ਜਿਹੜੀ ਵੇਵਲੈਂਥ ਆ, it is coming 1000 times as compared to the size of nucleus, and this is a stupid answer. So that's why here the proton electron theory, so it again get failed. So this proton electron theory, it get failed because it says that some electrons which are present within the nucleus, some electrons which are present outside the nucleus. Therefore in 1920, so Rutherford suggested neutron proton theory. ਸੋ ਰੈਦਰ 1920 ਦੇ ਵਿੱਚ ਹਾਲੇ ਤੱਕ ਕੋਈ ਜਿਹੜੀ ਨਿਊਟਰੋਨ ਦੀ ਡਿਸਕਵਰੀ ਨਹੀਂ ਹੋਈ ਸੀ, because neutron it get discovered in 1932 by Chadwick, but Rutherford ਨੇ 1920 ਦੇ ਵਿੱਚ ਜਿਹੜੀ ਥਿਊਰੀ ਪ੍ਰਪੋਜ਼ ਕੀਤੀ. So what Rutherford suggested that the electron does not exist in the nucleus in the free state. So what he said that electron does not exist in nucleus in free state, but it is bound with the positively charged proton. So they are bound with positive charged proton, and he predicted that these proton and electron, when they are in the bound state, so they form some another particle which is known as a neutral particle. So later this neutral particle, it has been discovered by Chadwick in 1932, and he gave the name of this particle as neutron. He done some experiment and he found that so there are some sort of particles so which are coming out. Now what James Chadwick explained, so Chadwick jehda hai, so in 1932, so he is an English British physicist. He observed that when beryllium foil is bombarded with high speed alpha particle, a radiation is emitted which consists of uncharged particle. So he is bombarding alpha particle with, he is bombarding alpha particle on a beryllium foil, and what he has observed, some sort of uncharged particles, he observed on his screen. So what he was doing is, he is shooting positive charged particle, but some uncharged particles having neutral charge, having no charge you can say, so it is coming out of these foil, and what he has observed that the mass of these neutral particle, that is of the order of 1.675 into 10 to the power minus 27 kg, and that is roughly close to the mass of proton. So if you calculate it in terms of atomic mass units, so this is the mass of neutron, while the mass of proton, which we generally say that is of the order of 1.0075 atomic mass unit. So mass of these neutral particle, it is quite close to the mass of these protons, while he also observed that these neutral particles or neutrons has extreme high penetration power. And they can also penetrate several meters in a concrete material. So high penetration power as compared to alpha particle. So like protons, neutrons also contribute to the mass of the atom, because the mass of the atom on atomic weight scale, that is equal to the sum of proton and neutron. ਹੁਣ ਕਿਸੇ ਵੀ ਜਿਹੜਾ ਐਟਮ ਦਾ ਜਿਹੜਾ ਮਾਸ ਆ, ਜਿਹਨੂੰ ਆਪਾਂ atomic weight ਵੀ ਕਹਿ ਦਿੰਦੇ ਆ, so that is equal to the mass of proton and neutrons so present in that particular atom. So that's why he favored this proton neutron theory, which has been proposed by the Rutherford, and he discovered that the number of protons is equal to the nuclear charge, and he defined that. So for a particular atom, so number of protons, so that is equal to the neutron charge, nuclear charge Z, and number of neutrons, so that is equal to A minus Z, and they both combine to make the atomic weight that is of the order of A. Now what are the other facts which support this proton neutron hypothesis? So facts to support proton neutron theory. So first is they discovered the wave mechanical consideration, and what they found using the same Heisenberg uncertainty principle, that the position of this neutron particle that can be of the order of 10 to power minus 14 meter, and from that you can calculate the change in momentum of this particle, so that is h bar over delta x, and it is coming of the order of 0.527 into 10 to power minus 20 joule second meter inverse, and the magnitude of the total energy we can calculate from this momentum, p square c square plus m naught square c the power 4 under root, and it is coming of the order of 940 mega electron volt, and this value is slightly greater than the rest mass energy of proton or neutron, because we know that the rest mass energy of proton and neutron that is of the order of 938.5 mega electron volt. So from these Heisenberg uncertainty principles, they suggest that the kinetic energy of neutron and proton in the nucleus that is of the order of few mega electron volt and roughly 938 mega electron volt, and it should be possible for a free neutron or proton to be present within the nucleus, and they suggested that so a proton or a neutron, so it is present in the nucleus. So second, they calculated the nuclear spin, and this theory removes the problem of nuclear spin as well, because both the proton and the neutrons, so they are having half integral spin, because both are fermions, so having half integral spin, and the resultant spin of total mass number A will be integral or half integral. It depends whether it is a even nuclei. If there is a even A, then it is having integral spin, and if there is a odd mass nuclei, then it is having half integral spin. So depending upon what type of atomic element we are talking about. So this nuclear spin has been well followed by this proton neutron hypothesis, and similarly the nuclear magnetic moment of the neutron that is of the order of the nuclear magnetic moment of the nucleus, and these results are quite comparable with the nucleus. So therefore nuclear magnetic moment of both proton and neutron, so they are consistent with those made for many different nuclei. And similarly, the wave mechanical considerations, so they find out the wavelength, and that is also of the order of the size of the nucleus. And from that they also said that so there is electron do not exist within the nucleus, but they are produced during radioactive disintegration. What is that disintegration? So when a radioactive element, so it loses some of the energy, it changes its identity to proton. When it is changed to neutron, so there is emission of positron particle. Along with that, so neutrino it is coming out, and when this neutrino it changes uh, some of its meson clouds. So this we will discuss in our next lecture. So what is this bond which is binding these protons and neutrons so together within the nuclei, and that is due to the meson clouds, or you can say that these particles are known as mesons or pions, and due to the transfer of these mesons or pions from proton to neutron and neutron to protons, so they are changing their identity, and when the neutron it transfers some of its mesons and it converted into proton. Along with that electron which is being emitted, and along with that, that is the antineutrino. So this is neutrino. So when neutrino, N-E-U-T-R-I-U, neutrinos, and this is antineutrino. So again these two particles, so they exist in pair. Similarly electron te positron jade hai, so all these particles, so they have change in charge but all the other properties are same. So similarly, so they have massless particles, so these neutrino and antineutrino, so they are massless particles. So that's why they easily jump from proton to neutron and changes their identity, but having half integral spin. So 1 by 2 spin, that is for these two particles. So now we will do one or two numericals related with this, and from tomorrow onwards we will discuss our main concept, that is the nuclear forces, and then we will go in detail about the deuteron problem, that is the two body problem, and how the proton proton interaction or neutron proton scatterings, so that we will discuss using the Schrodinger wave equation. Now let us do one numerical that is related with this alpha particle scattering experiment. A proton is accelerated to a high energy E and shoot at a nucleus of oxygen. In order to penetrate to the Coulomb barrier, ， , ， , ，, , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , , and reach the surface of oxygen nuclei so the value of the kinetic energy of this proton must be the value of E must be, and the options are 3.6 mega electron volt, 1.8 mega electron volt, 45 kilo electron volt, or 180 electron volt. Now what is the question? A proton which is being shoot out at a oxygen nucleus and which is having a energy E, and what should be the value of this minimum energy so that it cope up or it cover the Coulomb barrier of the oxygen nuclei and interact with the nucleus of this oxygen. And how we can calculate, because we know that so when the particle it is approaching toward the nuclei and it is losing its kinetic energy, and at a minimum interaction or the minimum distance between the proton and the nucleus, so that energy is converted into potential energy. So that is known as the minimum penetration energy, that is of the order of potential energy. Z square over 4 pi epsilon naught into R. Now here everything is we know because all values are constant, but we require this value of R, that is our impact parameter ਜਿਹਨੂੰ ਆਪਾਂ ਕਹਿ ਦਿੰਨੇ ਆ. So R that is of the order of R naught A 1 over 3. This we can calculate from the nuclear volume, and so R is directly proportional to mass cube root, and this becomes 8 Z, that is the charge on nucleus, that is 8 times charge on proton. E is the charge on electron, 10 to the power minus 19 square over 1.2 into 10 to the power minus 15 into R, that is A raised to power 1 by 3. A, that is the atomic mass of oxygen, that is 16 the power 1 over 3 multiplied by 9 into 10 to the power 9. And when you calculate it, so I will write here. So EP comes out to be 3.4 mega electron volt. So this you can done in your homework. The value of this minimum energy, that is of the order of 3.4 mega electron volt. So our correct option is option A. So it should be greater. So the value should be greater than this 3.4 mega electron volt, and only in that case it can penetrate and interact with this nuclei. ਹੁਣ 3.4 mega electron volt ਤੋਂ value ਕਿਹੜੀ ਜ਼ਿਆਦਾ ਹੈ, that is 3.6 mega electron volt. So that must be the energy of proton if he has to interact with the oxygen nuclei. So this is all about our today's lecture. Now if you have any queries, you can write in your comment box, or we can discuss over WhatsApp. So till then, goodbye, see you in the next lecture.